Factoring Part 6, Difference of Two Squares. This is the basic form of the difference of two squares. Difference, so you gotta have a minus two squares. A squared, B squared. Or some form like that. And when it factors, you're going to get the square root of the first term, square root of the second term, and minus plus. The order of this doesn't matter. You can have a plus b, then a minus b. That's it. Alright, I'm going to work some examples. One warning, the examples in this are relatively straightforward. If you want to see the more complicated examples, you'll have to look at Factoring Part 8. Okay, moving on. Factoring Part 8 will be a bunch of examples that I gave on a worksheet to my students. Alright, anyway, here we go. Number 1. So here we have a difference of two squares. X square root of x squared would be x. Square root of 36 is 6. And minus plus. That's it. Something about the number 1 confuses people. 1 is a perfect just about everything. One's a perfect square, one's a perfect cube. So here we got a perfect square minus a perfect square. 9, square root of 9 is 3. And we know what the square root of x squared is. And then 1 minus plus. Uh-oh, did I make a mistake? Look for common factors. There's a common factor of 2. So that would be what? 4x squared minus 9. Are those perfect squares? Well, 4 is perfect square, 9 is perfect square. So 2x3, 2x3 minus plus. That's it. Number 4. Perfect square, 5x minus 6, 5x plus 6. Common factor, 2. Okay, now it's perfect squares. Okay. Maybe these examples are too simple. Common factor of 3. Don't forget, 27 divided by 3 gives me 9. 3 divided by 3 gives me 1. You can take, these are perfect squares, but you can take a factor out. You should always take a common factor out. Alright, so here we can take out a 4. Oddly enough, it's still a difference of two squares. Don't let the y squared throw you off. Okay, sorry, that's it. Better examples maybe on Factoring Part 8. Bye-bye.